In this video, I will go over some of the highlights of what you read through in section 3.5 of your textbook dealing with continuous distributions. So in beginning to look at continuous distributions, we're going to take an example that was given in your textbook in section 3.5. So we start by taking a look at a histogram that you see on the slide, which is the distribution of heights of U.S. adults. So on the horizontal axis, you can clearly see the variable is height, and it's measured in centimeters. Now remember that the area under the entire curve, or all the area of the bars in the histogram, represent 100% of all U.S. adults. Therefore, the proportion of data that falls in the darkly shaded bins will give us the probability that a randomly selected U.S. adult is between 180 centimeters and 185 centimeters. So from the textbook, we are given that that proportion of the sample between 180 and 185 centimeters was 1,172 ten-thousandths, and each bin in the histogram had a width of 2.5 centimeters. So now, using the histogram that we had on the previous slide, suppose that we join the tops of the histogram bars with a smooth curve. This is starting to move us from looking at probability distributions for discrete variables, which we would use histograms for, to taking a look at a probability distribution for a continuous distribution. So since height is a continuous numerical variable, it's not discrete, we know that its probability density function is a smooth curve, as shown on the slide. So now that we are looking at the distribution of heights as being represented by a probability density function, we can talk again about the probability that a randomly selected or randomly sampled U.S. adult is between 180 and 185 centimeters by estimating it as the shaded area under the curve. And in this case, from our textbook, we saw that that value was approximately 1,157 ten-thousandths, which is very close to what we found a couple of slides back using the histogram. And of course, as is evident by looking at the histogram and curve that are shown on the slide, we can see that the difference between the two proportion or probability measures is due to the fact that we're leaving off some corners of the rectangles that are associated with our variable measure of 180 to 185 centimeters. So one last thing we need to say about continuous distributions and probabilities associated with them. By definition, since continuous probabilities are estimated as, quote, the area under the curve, end quote, the probability of a person being exactly 180 centimeters or any other exact height value would be defined as 0. And that should be clear from looking at the PowerPoint slide, because the width of a line, that is the width of a rectangle with a base width of 0, would have an area of 0 in that case.